السلام عليكم. Okay, brother Ali Ahmed, you were there in the last lecture. Yes, brother Ali. You can hear, brother. You finish question one? So I asked you to do question number two, I think, then, right? So done. Yes, brothers. The bus organized CPUs similar to figure as register 16 register with 32-bit in each, okay, an ALU and the destination decoder. So here, this each register is of size. So how many registers are there? 16 registers. Okay, here in this figure it is showing as 7 registers. Okay, but actually it is given as 16 16 registers. Okay, and the size of each register is suppose R1. It is size of each register is 32 bit. Okay, so size of each register is 32 bits. So like this, how many registers you have? R1 to R16. Okay, so you have 16 registers here, and the size of each register is 32 bit. So from this, we have to find how many multiplexers are there in the bus A and what is the size of each multiplexer. So here you have two questions. Okay, how many multiplexers are there in bus A? So you have to calculate number of mux and size of each mux. Okay, so to calculate number of mux, so what we have done, you can wait. Okay, so in question one, what he was doing is number of number of marks number of marks is equals to size of register, which is equal to how much? 32 bit. Okay, I will use other application where it is not important. Okay, so question one. So here in the question one, we have to solve number of marks is equal to size of register. Okay, so what is size of register here? 32. Okay, the number of multiplexer is 32. Okay, and second part is size of marks is equal to number of, yeah, what is the size of marks is equal to number of registers. Okay, so how many registers you have here? 16. So this is number of multiplexer and this is size of each multiplexer. So in this figure, I will just draw a figure roughly here for your reference. So here you have R1 to R16. Okay, so each line, okay, will implies, so R1 to R16. So okay, So this is part A. Okay, brother, if you want to speak, you can speak because I am just working out of the window. So you can speak to me through the black. Yes, yes. R1 to R16. Okay. So this is the first part, and second part is the how many selections inputs are needed in mux A and mux B. Okay, you can see here these lines are implies to mux. Okay, from here it is going to mux, and here it is also going into the mux. So what is size of mux? So what is size of mux? When you see the figure, what is size of mux, brothers? Yes,
Size of number.
size of mux is equal to 16. Okay, yes or no? So based upon the size, so suppose I have a multiplexer. So in multiplexer, I have 1 to 16 lines. Okay, so based upon the input, we can decide the selection. Okay, so how many selections are there? So if you have a 16 selection, that means how many input selection we need? N number. Okay, this n number is nothing but number of selection, sorry, number of selection line. So n is number of selection line, which depends upon the number of input. That means 2 power n is equal to 16. So how much it is? 2 power n equals to 2 power 4. So that means number of select input is equal to how much? Suppose
64.
we are writing for, so let me just recorrect this, for mux A and mux B, suppose. Okay, so for input for mux A and mux B is 2 power n, which is equal to 2 power 4, which implies n equal to 4. This is the number of selection. Okay, so C is decode size of the decoder. Okay, size of decoder. What is size of decoder? N cross m. So it is nothing but n is to 2 power n. So what is n here? What is n?
4.
4. 4 is to 2 power 4. That means 4 by 16 is the size of decoder. Whether you can take the picture for this.
Okay. Okay.
Okay.
Okay.
Next. So as we just did in the last class, D is ALU input, including input carrier. Okay, so here it is clear that it is ALU input including input and output carrier. Okay, so we are writing for ALU input. So ALU input is equal to, so what is the size of bus A? ALU input you can see in the figure. Let me show you the figure. The figure is with you, brothers. Figure is with you.
Yes, yes.
Okay, just see the figure. In the figure, it is clear that this is the figure. Suppose, okay, this is marks A, this is mux b. Okay, so this is number of input and this is input coming from the register. Okay, register, it is coming from the register. This is output to the ALU. Okay, so this is input to the ALU, right? And this is output to the ALU. So this input is nothing but size of this bus. Okay, so size of bus A plus size of bus B plus, okay, so this is size of bus A, okay, size of bus B, that means size of bus A this one, size of bus B this one, and here it is asking you to take consider the carrier also. So for carrier we take 1 bit. Okay,
Okay.
so size of bus A is how much? What is size of this bus? 32,
One.
and size of bus B is 32 plus 1, which is equal to 61. So this is the ALU input. So same way we'll take ALU out, okay,
Okay.
which is equal to size of output bus, okay, size of output bus, or you can write as I will just because there is no spacing. ALU output is equal to size of destination and in. So here also it is asking you to consider output carrier. So we will write plus 1 carrier. So size of destination is how much? 32 and 1. Because this size is how much? 32. This is also 32. So destination will be also 32.
Yes.
Okay.
Yes.
So 32, it will be 33. So ALU input is 65 and ALU output is 33. Okay. Just copy this. Now take the photo.
Okay. I see.
Done?
Done. Done.
So next is part E, control word. Okay, control word. So this to formation of control word, how many operations are given? 35 operation. 35 operations. Okay. So for accommodating 35 operation, how many bits we need? Suppose 2 power 4 is how much? 16. Okay, so here we need 4 bits to accommodate 16 operation, but we how many operation we have? So 2 power 5, which is equal to 32. Okay, still we need
We
more because
we
here
need
you can accommodate only
we
32 operation when you use 5 bits. So when you use 2 power
64.
6, it is how much? 64. That means I can write like this 2 power 6, which is less than 35, which is less than 2 power 6. So we need 6 bits, okay, for
Okay.
35 operation. Okay, so let us form the control word. So this is my control word. Okay, so here it is select A Okay, so here it is
Okay.
select A. Okay, select A, select B, and select D, and operation. Okay, so select A. What is size of select A? So when you write select A, go back to this figure.
32.
Okay, what is select A? What is select A? What is selection A? Here n equals to 4.
Yes.
So it is how much? 4. So it is how much? 4. Select DB is also 4. And select D is also for 4. And operation is for how many bits? Operation is for how many bits? Here the
5,
operation is for how much bits?
4, 6.
6 bits, right?
Yes.
So operation is also for 6 bits. So size
Uh,
of
35.
control word is equal to 4 plus 4 plus 4 plus 16. It is how much? How much? This is 4, 4, 4 plus 6. 28 bits. Okay, this is the size of control word. Take the picture. Is that clear, all of you?
Yes.
Okay.
Doctor,
Yeah.
Doctor,
Yes.
size of control. It is
This
4 plus 4 plus 4 plus 6.
I have written 16 here. Sorry, it is 16. It's not 16. It is, sorry, it will be 18, right?
Right.
So now the bus, you can hear, you can see my window, guys.
Yes, yes.
The bus organized CPU similar to the same figure what we have previously has four register in each. Okay, so has eight register with 4 bit in each. Okay, so here number of registers are given as how much? Here number of register
Uh,
is,
8.
sorry, so number of register equals to 8 and size of register is 4. Okay,
Okay.
so now ALU and destination decoder. So how many multiplexers are there in the bus A, and what is the size of each multiplexer? So how many multiplexers are there, brother?
4. No.
Multiplexer number of multiplexer is 4, and size of each multiplexer is, yes,
Wait, doctor.
8. So you can solve this. Please solve it and just tell me the answer. I'm waiting here. Just follow the previous same way and just solve it and tell me the answer. I'm waiting here.
Doctor,
Yeah.
number size of register, size of max is equal size of register.
No. Size of mux. Go back and see the question. Okay. The size of mux is equal to number of registers.
It is 8.
Yes.
And the number of max size of register is 4.
Yes.
And selection input, it is a 3. Okay. Size of max equal 8. 4. You can take another page. No problem. I take a picture. Four plus 1. 4 plus 1.
You were not getting my audio from that time?
What?
You were not getting my audio from that time? Hello?
No, no, no.
Sorry, it was muted. Sorry, brother. Now you can hear me?
Yes, yes.
Number of operation is given as how much?
14 is
14 operation, right?
yes.
So 14 operation means it will be how much? 2 power 3 is 8 and 2 power 4 is 16. So
16.
we need uh,
Okay.
2 power 3 which is less than 14 which is less than 2 power 4. That means we need
So that
4 bits. So control word is this is select, this is select A.
is
Sorry, it's not getting clear. So it is select A, select B, select D, and operation. What is select A? Size of select A is? What is size of select A?
4,
3.
3,
Select B is 3, and
3,
destination is also 3, and the operations is 4.
4.
So size of control word is how much? 3 plus 3 plus 3 plus 4, which is equal to 9 plus 4, which is nothing but 13. The size of control word. Okay. Here we complete question number 2.
Okay.
Wait for a while. Let the Ramas finish.
Okay.
Brother, you can take the picture of this, and I will just paste the new question here.
Okay, I take it.
Yes, but I will take question number three. Uh, the bus, the bus system of this figure, the previous figure, this figure. Okay, for this figure, the bus system is shown. Okay, have the following propagation delay time 30 nanosecond. Okay, you have the times are given as 30 nanosecond. Okay, let me share the screen with you. So I will upload this recorded version also in this channel. Okay, you can ask your friends, those who are not present today, they can listen to the this video and they can follow. Okay, I will give some assignments before. For assignment, they can follow this video. Okay, okay.
Okay.
So the bus. Yes, finish. Summarize finish here. The bus system figure has the following propagation delay time: 30 nanosecond for the signals to propagate through the multiplexer. Okay, and 80 nanosecond to perform add operation, and 20 nanosecond delay in the destination decoder, and 10 nanosecond to clock the data into destination register. What is the minimum clock cycle time that can be used to clock the data? Okay, so first of all, when we see this figure, okay, when you see this figure, so let me share this. Okay, so when you see this figure here, it is clearly telling you that there is an some propagation delay time. Okay, so the bus have the following propagation delay time: 30 nanosecond for the signal to propagate through the multiplexer. Okay, here it is taking as 30 nanosecond for the multiplexer. Okay, here it is taking as here it is taking as 30 nanoseconds. Okay, and 80 nanosecond to perform add operation. So in ALU, it is taking as how much? 80 nanosecond to perform 80 nanoseconds to perform add operation, and it is not it is delay time. Okay, and 20 nanosecond delay in the destination decoder, and 10 nanosecond to clock the data into destination decoder. So here 10 20 nanosecond in the destination decoder. Okay, when it is taking here, it is taking as for destination decoder, it is taking as the post delay time. It is given as 20 nanosecond in destination decoder, and 10 nanosecond to clock the data into destination. Suppose here it is taking as 10 nanosecond. Okay, so it is clearly understood that uh, there are some delay times. Okay, so let me write it clearly. Okay, so first thing is given as it. Suppose when you write through multiplexer, so question number 3, through mux, it is taking as how much time? 30 nanosecond, and to perform add operation, it is taking as how much time?
18
In
nanosecond.
ALU, it is taking as 18 nanosecond, and delay in destination decoder, delay in destination decoder, it is taking as
20 nanosecond.
20, right? Sorry, 20 nanosecond, and to destination register, it is taking as 10 nanosecond. So here it is asking you to calculate minimum clock cycle time. Okay, so minimum clock cycle time. Okay, so here you can see in the figure, when you go to the figure, it is clearly mentioned that here it is add operation. Okay, to perform in the multiplexer it is taking as 30 nanosecond, and here in the add, here in AL it is taking as 80 nanosecond. Here, from here to here it is taking as 10 nanosecond, and the delay in the destination decoder is taking as 20 nanosecond. Okay, suppose I will give you one example. Let us take one example. Okay, if you want to come from your home to the university, okay, so already you are delayed by suppose some time. Okay, so in between you have some signals here. Okay, one signal here, one signal here, and here you have coffee shop. Okay, so from home to the university it will take around, suppose, 15 minutes. Okay, and this signal delay time is suppose 1 minute. Okay, and here is also it is 1 minute. So there is a less chances that you will miss the signal. Okay, definitely when you come start from home you will get the signal, red light. Here also you will get the red light. Okay, here you have a coffee shop, and suppose you have here some bookstore. Okay, so when you start from home, so you will get the signal here for sure. So you will stop here. Okay, suppose from your home to this point it is taking you 3 minutes, and plus 1 minute is for, so total time it is taking as 15 minutes, plus 1 becomes how much, 2. If you stand at coffee shop, depends upon how much time it will take to make the coffee. Okay, so suppose from home to the university 15 minimum time. Okay, and 1 minute for the signal. Okay, you cannot avoid this signal because you cannot jump. If you jump signal you will get set, huh? So don't try to jump the signal. Okay, when you start from home you will get the signal, you have to stop for sure, you have to stop, this is the delay, you have to bear this delay. Okay, from this point to this point there is other signal, you have to bear this signal. Okay, you have to for sure you have to stop. Okay, suppose from here to here 3 minutes plus 4 minutes. Okay, let us divide like this, 5 minutes, 5 minutes, and 5 minutes. Okay, so from here to here it is 5 plus 1 6, 5 plus 1 how much, 6 6 12 second, 12 minutes it is taking you to reach, sorry, not, yeah, 12 till here. If you want to go to the coffee shop, okay, if you want to go to the coffee shop it will take you suppose 10 minutes. Okay, but now your class starts in the university, if your class is ready to start, so what you will do, you will not go to the coffee shop, right? You will delay, you will stop this and you will go directly go to the university campus. So that means from here to here it is taking as 15 plus 1 plus 1 it is 17, 17 minutes to reach you to the university. But due to the signal, sorry, actually it is taking 15 minutes you to reach the university, but due to the signal it is becoming 17 minutes. Okay, no problem. If you go to the coffee shop it will take plus 5 minutes more, so it will be how much, 22 seconds. But this is the maximum time, yes or no, this is the maximum time you can waste.
Okay.
Plus 5 minutes, it is the maximum time you can, you will waste 5 minutes here. But if you remove this 5 minutes, how much time it will take, 17 minutes including this signal delay times. Okay, so in the same question, so here in the same problem, so how, here you will have multiplexer. Okay, it has to pass through multiplexer for sure, 30 plus, it has to pass, it has to perform add operation. Okay, it will be no problem. Okay, now this, sorry, this time destination decoder I can remove. So this is not a minimum time. Okay, and plus 10. So it will be how much? 120 nanosecond. Got my point? Yes, guys.
Uh, yes, doctor. Why we delete 20 nanosecond?
Because suppose it is a delay, okay? It is a delay which will cause in the destination decoder, okay? So if we remove this delay time, so we can avoid this. This is a minimum time, okay? If it is asking you to calculate maximum clock cycle time, suppose, okay? So
Okay.
add everything. If you add all this, it will be 140 nanosecond. Okay, so it is for the maximum. Yeah, here it is not maximum. Here it is asking you to calculate the minimum clock cycle time. Understood?
No.
Got it?
Yes, yes.
Thank you very much. Just take the photo.
Then
Okay, next. Specify the control word that must be applied to processor to implement the following operations. Okay, so here we have. I'll draw here only. Okay, so so what is given here? R3 implies R1 plus R2. So R3 implies R1 plus R2. So what is R1 and R2? So this previously what we have done, we have formulated one control word, right? Okay. Here it is. It is coming. Okay. So it was select A, select B, select D, and operation. Yes or no? So we have done like this something operation. This is control word, right? Control word. Okay. So here this is selection A. Selection A means this is the select A, this is select B, and this is select D. This is select A, select B, and D is for the destination. So you will add R1 plus R2 and store the result in R3. So suppose if I replace this selection 1, sorry, selection A, okay, and selection B, selection D, and operation. So let us go to the sheet. I will show you this one. Okay. So it is our specify the control word that must apply to the processor implementing following micro. This is the micro operation. Okay. This is the micro operation. So when you go to this table, you can find R1, R2, R3, R4, R5, R6, R7. Okay. Here you can find this accordingly. And this is the same thing, selection A, selection B, and selection D. We will use this code for selection A, selection B, and selection D. So, and this is for the operation. This number is for the operation. Okay. So let us write here. This is nothing but R1. This is nothing but R2. Here it is R1. This is R2, and this is R3, this is R3, and this is operation. Let us write the operation. What is operation here? What is operation here? So this is select A, select B, select D, and operation. Okay, what is the operation here you are performing here? Brother, you have done this in the nursery?
um, I think so, yes. But it is and or
Yes, you have done this in the nursery? Yes. Fahad, can you hear me?
I don't. Yes, yes. I don't know, doctor.
Okay, no problem. So
we have a class tomorrow.
okay, no problem, no problem. So let us write like this. So no need. Okay. So it is. What are the operation here? R three implies R1 plus R2. Okay. We'll write R1, R2, R3, and operation is here we are adding. R means adding. Okay. So R1, when you go to this table, see what is R1? 001. R1 is
Yes.
001. R2 is 01,
010.
010. R3 is
011.
0
11.
011. And here operation is,
Uh,
what is operation here? Operation is add, right? When you go to this table, see the operation here, okay? Read the operation here. Transfer, increase, add A plus B, okay? If you see add A
yes.
plus B, what is equivalent to
Yes.
0 0 0
Zero zero
1
zero one
0
zero.
0 0 0 1 0.
Yes.
So this is the control word. Okay, got it? So this is question number,
Yes. Yes.
this is question number 4, right? 4. Okay. Understood, brothers?
Yes.
Okay.
Yes.
So shall we go to the next thing? So B is, so B is R3 implies R1 minus R2. Okay. What is selection A? First, tell me first. R1 is, this is R1 here, this is R2 here, and this is R3, and the operation is, what is the operation?
Subtract.
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 Okay, what is R1?
Zero zero
What is
one.
R2?
010.
R3 is,
011.
and operation is,
Uh, okay. Subtraction.
operation is subtract. Go to the table and see what is for the subtract. 0 0 1 0 1.
Zero zero
0 0
zero
1
zero
0.
one
This is the,
zero one.
yes, this is the control word. Okay. Now we will stop here and
Control
we
word.
will continue the rest thing in the next class, inshallah. Okay, I will upload this video in the Blackboard. In the YouTube, you can watch if you have any doubt. If you have any doubt, you can ask. Otherwise, you can leave.
Okay. Thank
Welcome. Done. Fahad, Ali, Ahmad Ali, and Fahad.
you. Yes.
Okay. If you have a doubt,
Okay.
you can leave.
The
Leave. Yes, brother.
the assignment. The assignment you will announce.
Yeah, yeah. I will announce the assignment on the Blackboard with a sheet. Okay.
Okay.
Okay, brothers.
Thank you.
Welcome. Assalamu.